This is the video for number 12 and number 13 from the Chapter 11 review. The directions state, write the polar equation for each equation given in rectangular form. So we've got number 12 and we've got number 13 here, and they are currently in rectangular form. We want to change it to polar form. So we're going to be getting rid of the x's and the y's and turning them into r's and thetas. So a quick recap, if you look down at the bottom of the page here, I kind of drawn out a just kind of a coordinate plane here, and you'll see that we've got this right triangle in it. In our right triangle here, right, our hypotenuse here is r, and then like obviously our x coordinate here, our horizontal side is x, and our vertical side is our y. Okay, this is angle theta. So we have a couple little formulas that you learned in this chapter to help us convert between our x's and y's to our r's and thetas. So let's just kind of derive those real quick so we remember where they're coming from. Let's start out here with kind of like x. If I wanted to come up with an expression for x using what we have down here, okay? So we know here the relationship between x and r, when we're talking about a right triangle here, x, when we compare it to theta, is the adjacent side, and r is the hypotenuse. So that would be like saying here the cosine of theta should equal the ratio of x over r. Okay, now if I take that here and I wanted to get x by itself, we could take it and we could multiply both sides of this equation by an r, and we get that formula that we were been using in the past here. X is going to equal r times the cosine of theta. Now similarly with our y's, right, we're talking about we want an equation using y is the opposite side, and r is obviously still our hypotenuse. So we could say here that our sine of theta is going to equal the opposite side, which is y, divided by the hypotenuse, which is r. And if we wanted to come up with our other equation we've been using, we'd multiply both sides by r again, and we get that formula here that r times the sine of theta equals ry. So we're going to use these right now. So looking at 12 states that we have y is equal to 4 over x. Okay, so what we want to do here, if I think about this as if y is really the same thing as r times the sine of theta, let's substitute that in. I've got r times the sine of theta. Right now it equals 4 over x, but I can replace my x with r times the cosine of theta. So when I write this here, I've got 4 divided by r times the cosine of theta. Okay, so what we want to try to do here is solve it for r. We want r to be by itself, just like when we a lot of times have y by itself. Now it doesn't always work perfectly, but in this case I think it should. Let's first of all, let's get rid of the r that's in the denominator over here. Let's multiply times r on both sides. So we've got r squared times the sine of theta equals 4 over, and remember this r and this r would cancel out, so it's just 4 over the cosine of theta. To isolate our r's, to get rid of our sine of theta, let's just take it here and let's multiply by 1 over the sine. It's like we're dividing both sides by sine, right? So when we do that, our sines end up canceling out, and now we're left with an r squared over here is equal to 4 times 1 gives me 4, and on the bottom, cosine of theta times the sine of theta, right, gives us, however you wish to write it. You could write cosine of theta times the sine. Order doesn't matter there. So that would be one form of our answer there, right? You could just leave it as r squared equals 4 over the sine of theta times the cosine of theta. If you wanted to, you could also take the square root of each side and have r equals positive or negative square root of 4 over the sine of theta times the cosine of theta. That would be acceptable as well. That is the answers for number 12. Let's go ahead and jump into number 13 now. Okay, so this one here, where we didn't even talk about what this one looked like, this one was a hyperbola, right? This one over here is just a straight line. So let's take this here and let's think about what we could do. We have to get rid of our x's and our y's, so we could end up kind of looking at it the same way here, right? We could use these expressions that we came up with down here for x and y and substitute them in for the x's and the y's. If we do that here, this is what we have. 3 times, instead of x, right, we're going to have r times the cosine of theta minus 5, and then instead of our y here, we could put in r times the sine of theta. That still equals 10. So if I rewrite this, right, I don't have to distribute because it's all multiplication here. 3 times r times the cosine of theta is 3 times r times the cosine of theta. Same thing here with the 5. It's like negative 5r times the sine of theta equals 10. And now we need to get it so we have just an r by itself. Well, since r is a factor here and r is a factor here, let's just factor out our greatest common factor as r. So when we do that, we have r times the quantity of 3 times the cosine of theta minus 5 times the sine of theta equals 10. And now to solve it for r, let's just divide each side by this big nasty looking quantity here. That's a 5. All right, we're going to divide it on this side. We're also going to divide it on this side. So when we get to our answer, we should have r equals, sorry, I'm a little out of room there, 10 divided by 3 times the cosine of theta minus 5 times the sine of theta. And that would be our polar equation there. This is problems number 12 and 13. Now remember, if you wanted to check them, you could go in here and you could graph this in function mode on your calculator, and you could graph this in polar mode on your calculator, and you should end up with the same graphs there. If you have questions about that, just reach out to me here and I will help you. I know that some of you are a little confused on the calculator and how to do things, but I've only had a couple of you ask me, hey, how do I do this? So I'm going to leave it up to you. If you have questions, reach out to me.